Hello guys, welcome back. This is going to be the final video of this lab series. So video 3 of 3. This is going to be configuring spanning tree protocol, um, specifically making some interfaces activate instantly. Um, also having one route preferred via spanning tree protocol HSRP and to go to the network. Um, let's go ahead and get started. So what we'll do first, let's go to the switch. We'll say enable conf t spanning tree question mark mode question mark. Actually, I'm not gonna bother with that. These interfaces here, so interface fast Ethernet 0/1 through fast Ethernet 0/4. I can use range for this just because what we're gonna do, interface range, fast Ethernet 1 through 4. We're gonna specify, sorry, tree. So this is more of a security feature of spanning tree protocol. And what we'll do is we're going to say, we're going to use this command here, bpdu guard. Oops, question mark, enable, question mark, you right? And what that does, so basically these switches use messages, it's only switch to switch via, they're called BPDU messages, and they try to determine which switch will basically rule them all, so to speak. Basically which switch will turn into the root switch and all that kind of stuff, but it can really mess you up if you have a network set up already and someone accidentally connects a outside switch or whatever to this switch and messes up the configuration. So it's best practice if you have end user interfaces such as these to enable some sort of security on spanning trees, such as spanning tree BPDU guard. What will happen is, let's say someone accidentally plugs in a switch here, it will send a BPDU if there's no if uh if it's trying to see what switch will be root. This switch, since it has BPDU guard here enabled, it's going to say, oh, no, you don't. And it's going to error disable this interface. So it's more of a security thing. Um, but it's good to have because if 5, 10 years down the road comes and someone disconnects this device and puts another device there, it protects your network. Now, on the other hand, if your devices are connected to other, like let's say for example, if switch is connected to another network device such as a router or a switch, you can enable something. I'll show you real quick. Interface range gig 0/1 to 2. We can enable something called spanning tree port fast, and we'll get a whole bunch of stuff here. It basically, I don't know if you remember earlier when we shut down some ports and enabled ports, one of these sides was green and another side was orange. What's happening is spanning tree protocol is checking for any kind of issues such as loops or things that could harm the network. So it takes that a good 45 seconds to go through its whole listening learning process. With PortFast, we basically say, oh, no, we don't need that. We can just start ASAP. So that's basically what that does. Once they do right, and of course, since we enabled that on this side, we want to also do the same thing on the next side. So we'll say interface 0/1, spanning tree port fast. I'm using the tab to make it auto write. Same thing with this side. Enable comma T interface G 0/. It's be a little time consuming because I got a lot of network parentheses here. Let's give 0/2, spanning tree, port fast. There we go. And then we can also do that on our Ether channel as well. So let's go ahead and say interface EO1, spanning tree, port fast. Do right. And interface P1, spanning tree, port fast. Right. And finally to the other, all these connections here. Let's, for the sake of time, let's not do that. But yeah, these you could enable spanning tree port fast here. All right, so now we want to also prioritize traffic for VLAN 10. How would we do that? Well, we are going this way ideally since VLAN 10 is using since VLAN 10 is prioritizing this route for HSRP. What we would do is go onto this actual router, switch here, sorry, and we're going to configure spanning tree globally here. Question mark. We want to configure which VLAN we want to configure in such a way. And we're going to say priority, question mark. Now with spanning tree priority, the lower the number, the better. So we want this to be the priority. We'll make it 4096. And we also want to say spanning tree VLAN 10, question mark, root, question mark, primary, question mark, carriage return, do right. I want to set, since I'm doing the roots numbers manually, let's set uh, let's set this one up to be the counter of that. So we're going to say spanning tree Elon question mark 10 question mark. Oh wait, this is interface. I don't want to. I don't want to. Spanning tree Elon question mark 10 question mark priority question mark 4096. I don't want to use 4096 because I want a higher number than that. Let's go ahead and say, I don't know, 8192. I think that's double. Pretty sure. All right. And we'll also configure this as the secondary. Root, secondary, question mark, right. All right, so spanning tree, it will prefer this route for VLAN 10 to go to this router and to the outside ISP via this route. But if in case anything fails here, they will go this way. So let's go ahead and do that on this one as well. Oh, wait, sorry. Let's go configure VLAN 20, but it's going to be the opposite. So let's say spanning tree VLAN 20, question mark, priority, question mark, 8192, question mark, perfect, spanning tree VLAN 20, question mark, root. This is going to be the secondary for VLAN 20. Do right. And I'm going to do the opposite here. Spanning tree VLAN 20. This one's going to take priority. Question mark 4096. The lower the priority is what we want. Spanning tree VLAN 20. Root primary. And that's it. Do right. All right. With this switch, I want to say spanning tree VLAN. I don't want any issues um, with this switch trying to take um priority over the other ones. So VLAN 10, I'm gonna say priority question mark, and I'm gonna intentionally mess it up because 5 is not valid, and it will show me which numbers I can enter. And I want it to be larger than these two. So let's say 12288. Oh, sorry, 12288, like that. Spanning tree line 20. Priority question mark 12288. You're right. And that should be it with setting up spanning tree. Just the very basics of it. I'm not going to go too deep into it. But yeah, I would also configure these as actually I am gonna well nah, I'm not gonna bother. It's just too time consuming. But now everything should be set up. So we're gonna just test out some things. And what I'm gonna do is I'm gonna shut down these two routers and make sure every VLAN 10 and VLAN 20 can travel. I'll shut down router 1. I'll make sure VLAN 10 and VLAN 20 can get to the network still, and vice versa. I'll turn it back on. I'll shut down router 2, and we'll see if the same still holds truth. So let's find out. And the way I'm going to shut these down is I'm just going to turn off the interfaces. So let's see. This is the moment of truth here. Global interface G/0 shut interface. G0/2. I want to shut down my redundant links too. Shut interface 0/3/1 shut. Okay, so router 1 is completely detached from the network. So hopefully traffic will go this way. This is true for VLAN 10 and VLAN 20. And traffic coming from uh, the internet will be going this way as well. All right, so let's go ahead and test it out. First, since our uh, router 1 is down, let me just test DHCP. As we can see, it's still up. But what if I wanted to renew my DHCP? IP config release, IP config renew. IP, oops, no space, sorry guys. Renew. Do I get a new address? Yes, I do, perfect. Okay, now let's see, can I ping 92.1? So, can I ping the other VLAN? Oh wait, I can't because this is an invalid IP address. What IP is being used by this? 50? So can I ping this? Let's find out. Let's find out. Ping? Oh, that's okay because I didn't have any device set up with .1. Ping 192.168.2.50. So should still work. There we go. That's what we want to see. As long as your ICMP it's like this and has a time to live thing here, you're fine. We can do it again and we'll get all of it to work. Oh, can I ping the outside network? 10.10. Now with this, I got to be careful because I shut down 10.10.10.1 or 10.10.10.2, so they would definitely not work. But 10.10.20.2 should still work. Dot 20.2. There we go. So it can reach the outside network. Perfect. So we know VLAN 10 is good. We're going to check VLAN 20, and we're also going to check the outside network, see if I can still talk to these guys. So, okay, let me say our default gateway is looking good. I want to see if what happens if I say, let's test the HCP first. So IP config release. IP config remove. Okay, good. It looks like DHCP split core is working fine. This router's giving us the DHCP now. So let's see, can I ping VLAN 10? Perfect, I can. Can I ping the outside network? Good, I can. So we know VLAN, inner VLAN connectivity is good. Let's make sure the outside can ping inside. One thing I forgot to do is it would be best practice for me to include a default route as well. So it would be like IP route 00000000 to um, VLANs 10 to 20, but this is fine for now. To ping 192.168.1.50. Perfect. Okay, let's push up and just change the 1 to 2 to see VLAN 20 connectivity. Perfect. All right, so we know HSRP is working fine, all that. DHCP seems working great too, and I can still have two-way connectivity. But let's bring everything back up. Let's see. Another shut. Shut. Which one was the last one we come back? Let's see. Okay, 0/2. Interface 0/2. Shut. Right. So everything's back up. Now I'm gonna turn off this one. That's okay. That's because we turned off a lot of the interfaces. So we'll shut down gig 0/1, gig 0/2. This just means that OSPF has formed a neighbor adjacency again. Oh, whoops. I didn't mean to do that. Sorry, guys. T interface G interface range G 0/1 to 2 shut, and then interface serial 0/3/ what is this? 0. No, shut. Oh no, start. I'll do the opposite this time. All right, so now we are simulating this router going down. All interfaces are shut off from it. Can this VLAN 10 reach the outside network? Can VLAN 20 reach the outside network? And vice versa, can outside network reach VLAN 10 and 20? And will DHCP still work? Let's find out. Let's use this PC this time. Let's see. So, what is my current IP address of this? 51, okay. Looks like it's already, it looks like it worked automatically. IP config, let's see, let's see, IP config release, IP config renew. GP request failed. I wonder why it failed. I should still be able to get, say, static from the DHCP. I should still be able to get a DHCP address. IP address. Let's see, is it the same for this? Let's see that. All right, that's okay. We'll figure it out. IP config, IP config slash release, IP config slash So I'm gonna check. It doesn't look like the HTTP is gonna work on router one. I'm not sure if it's a Cisco CCNA bug. Cisco packet tracer bug. Let's say one. Just to double check out work here. Domain name right. Okay, that's probably the problem. So let's go ahead and just go back to IP exit, IP DHCP blue, IP DHCP full blue. No domain IP DHCP full yellow. Oops. What is the issue? Okay, search from minimal configuration mode. IP DHCP full yellow. No domain name. Right. Um, let me just make sure I missed that up. Here's one. Okay, so I did miss it up. That's what happened. So I'm gonna say IP DHCP for yellow. No domain name. All right, let's fix it. Page one. All right, let's see if that was our issue. So we don't actually have a domain name. Can I get a stack DHCP? Can I get a DHCP address? Unslagger? Probably not. Hmm. 1.50 to yeah, we should get something under 50. Hmm. Let me think. Maybe this doesn't work on Cisco Packet Tracer. I don't know. If I can't figure it out, I'll make another video showing me troubleshooting it and figuring out after that. But that should give us what we want as far as DHCP should give us a new IP address, if I'm not mistaken. Yeah, it's not working. The only thing I can think of, the only thing I can think of is maybe it's a bug via Cisco Packet Tracer. And usually when I have stuff like that happen, I can just say reload, and the network's gonna go down for a minute. But let's just see what happens when I reload that. I don't want to spend too much time trying to get the DHCP um split core working. If it, I don't want to take too long on this video. I just want to make sure I can connect. And like I said, I'll make a little 5-minute video on how I fixed it. If that's, if I can't get it back up. So I'll say enable T, do show one. Make sure DHCP is looking good. Awesome. This is the stuff we want to see. Just making sure I didn't misconfigure anything. It looks like everything's fine. Yeah, I should be able to get any IP from 1 to 49 at this point. Let me just see now, since I've restarted that. Command prompt IP config. We can see our IP address is an old one because it's above 49. Release. Renew. There it goes. Oh, did it work? Okay, yeah, it did work this time. It was a Cisco packet tracer bug. If you ever get anything like that, I get them quite often. You just reload the device and it works. I love Cisco Packet Tracer. I've spent hundreds of hours on this, but it does have its bugs. But for what it is, this is just an amazing simulation, to be honest. Um, DHCP is gonna work now. Perfect. I just had to reload the device. Awesome. That's what we want to see. So, sorry about the wait, guys. Can I connect to the outside network? Well, let's see first. Is there inter VLAN connectivity? So can I talk to VLAN uh, uh, 20? I think one of the addresses is probably 1, since the DHCP servers swapped via split core. Let's find out. Quest timed out. There we go. That's what we want to see. Oh, guys, by the way, if your first ICMP message fails, don't panic. That's just ARP. The first ARP is being lost because it doesn't know the new IP address of this device. That's why consecutive um, pings work flawlessly because it already knows the address. All right, so then I can say, can VLAN 10 connect to the outside internet? I'm using 10.10.10 this time instead of 20. Let me just confirm that. Yep, we'll go on the north, the northern route here. Can it work? We're gonna find out. Destination host. So with that, we're gonna fix that. I will probably get the same error with this one. Let's first confirm network connectivity, inter VLAN connectivity. I'm not gonna push that because it already works. Ping 192.168.1 .1. There we go. I'm probably gonna get the destination unreachable on this. That's basically just the computer, the process saying, "Hey, I don't have any route outside to the network." So a real easy fix to do that. We can go like this on the internet service provider side. First, let's call T IP route. Oh wait, say do show IP route. And look at that. There is no routes. I'm not quite sure why that is, because I did configure floating static routes. But if I were to say IP routes zero, destination is going to be 192.168.1.0, 255.255.255.0 from 10.10. Let's see, 10.1 is our next hop. Make it a floating static route of 120. That should be fine. Same thing, IP route 192.168.2.0, 255.255. I might have forgot to do this, to be honest. There we go. These can be the same administrative distance because they're going to different networks, so it's totally fine. You're right. And now that that's done, I should be able to ping. Okay. And oh, you know what it is? OSPF is down because there's no neighbor adjacency here, and this is a passive interface. I have to also include IP routes here because there was currently no route going from VLAN 10 and 20 um, to the outside network. IP route, we're going to say destination is going to be 0, 0, 0, 0, 0, 0, 0, 0. This is just specifying it can be any network, any subnet, and uh, next hop is going to be 10.10.10.1. Whoops, 2. Ooh, I had to do that for this one as well, even though it's down. 0, 0, 0, 0, 10.10.20.0. There we go. That should solve our problems. That's just, I want to make sure though, because I don't like, and I would probably have to change the administrative distance because I think it would take precedence over OSPF. Destination host unreachable. Okay, let's try something else. IP route 192.168.1.0, 255.255.255.0. Uh, Everything looks good. Let me just see. Can I ping? Hmm. Yeah, I don't know if this is gonna work once I set up. Let me just do this. I'm gonna remove the passive interface. So let's go ahead and say interface. S serial. No, let's go to router. OSPF1. No passive interface. uh, Serial 0/3/1. Right? Same thing with this. So I just gonna let it take precedence. I use OSPF. Interface. Serial. Oh, wait. Router OSPF1. No passive interface of serial 0/3/0. Doing right. Right. OSPF1 or 10.10.20.0 0, 0, 0, 0, 3 1 or 10.10.10.0 area 1, right? So router ID 3333. Okay. Do a little bit router. Also default information version 8. All right. That's let's see. Yes. I'm gonna get this network. Oof, okay, good. All good. Ready to get back up and running. See? All right. Let's see what our looks like. It's so strange. Why is this? Why is this interface down? You know what? Maybe I didn't turn it back on. Man, interface serial 0/3/1. Shut. That might have been it, guys. I did all that for nothing. I didn't have to configure OSPF at all. It works now. So I'm an idiot. I didn't turn that back on. Just make sure I can connect to this. Yep. So network's good now. Um, the last 5 minutes you saw me configure different methods to try to connect these routes. You probably saw the IP route 0000 0000. That basically means, so say for example, if router 0 wants to talk to VLAN 10 or VLAN 20, instead of using two commands, one to destination VLAN 10 and one to VLAN destination VLAN 20, I could just say 0000 0000, and that basically specifies to any and all networks. And then I could say then from the next hop. Basically does the same thing. This one should be participating now. OSPF. To be honest, I didn't want this to participate in OSPF because I wanted this to be the internet service provider router. So now that I know the route works, and I think it's just I had all my stuff right, I just forgot to turn an interface up. I think what I will do is turn off OSPF on this router. So I'll say no OSPF one area. No OSPF one router OSPF one. You right? Okay, so OSPF is not working now on this. This shouldn't be working at all. Yep. I don't even need OSPF on that. Sorry guys, I lied. I don't need OSPF. I just was stupid and didn't enable this interface when I turned back on. So I am gonna go back in here. I don't want there to be a OSPF advertisement on this serial link. Here you go, that's what I want. I'm gonna say exit router OSPF one passive interface serial 0/3/1. You right? And that should not be able to, that should prevent uh, neighbor adjacency messages to be sent to the internet service provider. All right, so I can still talk to the outside network. Let's just double check since I did that. Perfect. That's it. I just had the interface down. All right, let's bring this one back up. Interface range, exit, interface range. We'll say, what are my interfaces that I need up? Interface range G0/1 to 2, shut, interface serial 0/3/0, shut. Do right. Awesome. Well, guys, that is my network. This is going to conclude this video series. Sorry about all the unnecessary troubleshooting. Um, Let me make sure OSPF is not on this router anymore. Do show IP route. Good, I have my two static routes with the administrative distance a little bit above OSPF. I didn't have to do that since OSPF wasn't on this router. But um, perfect. Did we form a neighbor adjacencies? Okay, good. This is back to standby. Good, that's what we want. This one should be back to being active. Awesome. Neighbor adjacencies are formed. And yeah, that's it. Thank you all for watching. Thank you for sticking around. And I'll be sure to post more videos like this. Have a good day.